Okay, in this video, we're going to create a tool called the Wallmaker. It's a pretty simple tool. You draw a line, and it creates a wall. Draw another line, it creates a wall. You can delete lines, you can add new lines. So the basic idea behind this tool is not the complexity involved in making a wall. It's pretty straightforward extrusion. And what we'll discuss in this tutorial is to talk about how to create an interface. As you can see, there's kind of this split left screen, right screen difference where you see the input geometry in one and the final geometry in the other. The two views are synced together. I can draw things and delete geometry without ever having to use Grasshopper, and what shows up in the same world space is different for each perspective. And we're going to kind of go over these elements of this tool, and specifically how to kind of move from just creating a Grasshopper component to creating a tool environment. And so the simple wall example is there mostly so that you can understand not so much how the computation part of this tool works, but more about what makes this tool feel like a tool. I'm going to start up with a new Grasshopper file. And one of the first things I'm going to use is Geometry Pipeline. I just double-clicked on the background. You can also see where this is by going into Params, Geometry Pipeline. And this Geometry Pipeline essentially just takes in whatever is there in Rhino and brings it into Grasshopper. Normally, when you bring in reference Rhino geometry into Grasshopper, you have to oftentimes select explicitly which geometry you want to use. So if we have these 4 curves, usually you have to go type in geometry, right-click, hit Set Multiple Geometries, and then this geometry object will reference what's on the left, the Rhino geometry. And you can see that because when you click on it, the geometry in the Rhino window turns green. With a pipeline, however, you can have this kind of automatically happen, because the downside with this geometry is that if you add a new piece of geometry, this new piece is not referenced explicitly, so you have to then go in and select all 5 and highlight. And if I open a panel, typing in a quote is a shortcut for a panel. You can see I have 5 pieces of geometry. And if I delete some things, you can see there's a little error because it can't find what it was referencing and will find null. So the upside of using these components to reference geometry is that you get to really explicitly define what geometry from Rhino you're going to use. The downside is that you can't just kind of add and delete new geometry. And this is where the geometry pipeline comes in. So right now this has layer, so it says like from which layer am I going to grab geometry from. This says name, so what's the name of the geometry. And by the way, most oftentimes in Grasshopper, most of the geometry you'll create doesn't have a name, but if you want to, you could make that happen by going into the properties window of each piece of geometry and setting a name here. And there's also a type you can filter for: points, lines, B-wraps, meshes. And you can also get some of this by right-clicking. In our case, if we said I want curves, this thing will highlight. And if we see what outputs we get 4 pieces of geometry. If I delete them, it automatically updates. And so this is really incredibly helpful. It's kind of difficult to underestimate how helpful this can be. Because this can grab geometry as you need. And not only that, you can define a very specific layer. So I'm going to rename this layer called Wall Layer. And I'm going to name this layer Wall Layer also. One thing you have to be careful is that you don't have any extra spaces, or that this is case sensitive, so that all the capitalization is done exactly the same as your layer. So now if I do that, I can have some geometry that's not grabbed by the pipeline and other geometry that is grabbed by the pipeline. You can see this difference here. So that's the geometry pipeline component. And the reason why this is so helpful should happen as soon as we start to do things with it. So if we start to extrude all our geometry using the extrude command in the unit Z, so in the Z-axis direction upwards with some units, you can see all of a sudden we have these walls. And I'm using some shortcuts here. I'm double-clicking, and this is a way to quickly add Grasshopper components in. You can also go and find them from these menus. Another shortcut is that if you type in a number, oftentimes it will help you create a slider that is already set to that number. So normally you may have to go in and find a slider, bring it down here, double-click, set the number. Instead, you can just double-click and type in a number and it'll create a slider for you. And if you want to create a panel, you can double-click and hit quotes. Or, if you want to get fancy, you can type in quotes, hello, and it'll automatically put that word in there for you. So those are some of the shortcuts I'm using. So now I have this geometry pipeline extruded in the Z direction by a factor of 8. And so we can kind of continue drawing or deleting, and it'll automatically create and delete our walls for us. Now the next thing, there are kind of three main components to kind of creating a tool, or at least three, and there's a lot of different ways to create a tool and turn a tool into an interface. One of them is the custom preview component. So you'll notice that everything in Grasshopper wants to show things onto the screen. So if I click on this, the geometry pipeline, the geometry it references turns green. If you highlight on extrude, the geometry that's extruded turns green. And if I plug this into here, it'll turn this shade of purple. And what this custom preview does is it takes whatever geometry is coming in and previews it, or shows it with a very specific color. And there's a geometry that it wants and a material that it wants. You can type in swatch, color swatch, and that will create a color. Again, kind of, if you double click on this color part, you'll get a color picker. It's got a nice blue. And if you connect it to the material, it'll show a bluish color. And you'll notice, if you notice, the blue is actually not the same color as what's here. It's because there's all this actually other geometry that it's trying to show. So you can highlight everything else other than the custom preview, middle click, and select the blindfolded person, turning everything else off. So now you kind of have a slightly more kind of controlled or visually attractive version, because we're controlling what the color of the walls are. Now, one thing that's fun about this custom preview component is that if you right-click on it, there's a viewport filter. And what this means is that it's saying, I will only preview this geometry for viewports that have this name. So if we say we only wanted to see the walls in a viewport that says perspective, we could type in perspective, hit enter, and all of a sudden, in all but the perspective window, the walls are hidden. This is only previewing the wall window. So every other window, this is not visible, and only the preview is visible in the perspective. And so we can do some fun things with this. You know, we could add another preview component. I just copy and pasted there. I'll do that again. I'll copy, paste, Control-C, Control-V, and you can select some of the original geometry and maybe try to make them a different color, but also pipe them in the process. Whoops, that's not the right pipe. Apologize, pipe. Here we go. So I can use the pipe command, hide this pipe, and then I can right-click and say, I actually want this just in the top perspective. And so now you can see that my geometry is thick and my walls are thin. And this is like this is happening in the exact same 3D space. It's not two different spaces, you can see that if I create, say, a sphere, if I change my viewport to shaded so we can see the sphere, you can see the sphere is in the same place. It's just Grasshopper is showing the walls in one view and the control geometry, or the input lines, in another view. So that's a second aspect, and I highly recommend that whenever you make a tool, you really hide everything but custom previews, so that you can kind of carefully control what your tool looks like. We probably have talked about this in class, but how your tool looks like, I think, is one of the elements that changes how you use it. It's not just a visual design element, and actually will change how you feel about your tool depending on if something you're using is bolded or colored differently or something like that. Okay, so this is pretty cool so far. Now the next step is going to require a plugin called Flounder. And you can find it up here, and if you don't have it, you should probably see my other video on how to install plugins in Grasshopper. And the other video will explicitly talk about going to food4rhino.com. So in Flounder, there are 3 plugins. One's called Get Camera, Sync Camera, and it should say Put Camera. And we're going to use initially just the we're going to use Get and Put. Even though this says Sync, that's not what it means. They're actually different. So this is a kind of bug in the plugin. So what this does is it finds the camera location of one perspective. And I'm not sure if you've experimented, but in Rhino, if you go into a perspective, type in camera, and hit show, you can see, other than the viewport you typed in, so if you have to click on the perspective and type in camera, you can see the camera location of the perspective view in the top view. So you can actually go ahead and move this around from the top. So the camera is modeled as this, I got this funky perspective. The camera is modeled as this virtual camera object that you can move around. And I'm going to try to reset my viewpoint. Whoops. It kind of worked. I'm going to set C-plane, world, top. There we go. Okay, so now we're back to normal. So, so yeah, the camera is modeled as a 3D object, and what GetFlounder camera will do is it will get the location of that camera, all that information. And it turns out for any camera in Rhino, there are 4 things that are necessary to describe the status of the camera: the location, where it is, target, what you're looking at, lens length, which is kind of the angle of the camera, or if you've have some photography background, the focal length, and up, which is which way is up, because you could be standing in the same location, looking at the same thing, but you could be upside down, hanging from the monkey bars. So what I'm going to do is I'm going to make a panel, type in a quote, perspective, and hit enter, and I'm going to use it as a viewport name, and because I'm going to try to get the camera location of this perspective, and this viewport is called perspective. And I'm going to type in looking for Boolean toggle, so Boolean toggle. I'm going to connect that to activate. When I turn that on, what I see is a location, and if I move my camera and turn it off and turn it on, it actually changes. So this will give me the location, the target, the lens length, and the up direction. You might ask though why this doesn't actively update as I move around. And the reason why that is because GetFlounder camera, everything in Grasshopper reruns when it feels that something that came in as an input changed. And since none of these have been changing, even though I'm moving around, GetFlounder camera only runs once. A way to get around this is to use the timer component. So if you could type in timer. What this timer does is it's this little ovaloid shaped thing, filleted rectangle, and if you drag from this red arrow up to things, it lets you stick this line onto anything, and if you stick it onto get flounder camera, what this does is that this will forcibly say, hey, whatever this is connected to, refresh every 1 second. So I can move around, and you'll see that the numbers on the right change every once in a while, every 1 second. You can right click on the timer, go to interval, and actually change it to say 100 milliseconds, so it's changing once every 10 seconds. And if you feel exciting, you can change it to 50 milliseconds or even 20 milliseconds. But let's say we'll keep it at let's keep it at 100 for now. So the timer will point to anything and say, hey, compute this again. Even you just compute this every 100 milliseconds no matter what. The upside of this is that it helps us do things like get feedback from the screen. The downside is that it literally runs whatever is it's connected to every 100 milliseconds, which means that it will also run whatever this thing is connected to 100 milliseconds. So if your timer is connected to something that takes a long time, then your Grasshopper script may have the chance to freeze and lock down. So you can turn off timers by double-clicking on the red arrow, and then if you double-click on it again, it'll turn back on. And so now while this is on, we can get the data of this camera. So what I'm actually going to do before we keep on going with Grasshopper is actually go into Rhino and go to View Display Options. Actually, no. I'm going to click on the small triangle next to the viewport and go to Set View and go to Named Views. And you should see like a little tab show up here if it hasn't already. And while you're on perspective view, you can save a view. So you might already know how to do this, but I'm going to set a view called Model Perspective. And what the named views can do is you can like save a particular viewpoint. So I've zoomed really far out, but if you double click, it'll save the exact camera location. This is really helpful when you're rendering and you want to kind of save particular viewpoints. I'm going to click on the top, also double click. So these are both in model perspective. I'm also going to save as and make another viewport called view perspective. And I'm going to try to have the model perspective on the left and the view perspective on the right. So now, what this means we can do is we're going to try to synchronize, as we move stuff in the model perspective, it'll change in the view. And I'll change our viewport name to be model perspective. And then I'm actually going to connect, not this one, but the other flounder camera. I'm going to connect the location to location, the target to target, the lens to lens, the up to up. I'm going to connect true to activate, and I'm going to make another panel that's called view perspective. So what this is doing, it's saying get the location position of the camera and then set view perspective's location to be the exact same. And you just notice that change. And so if you move the left, don't move the right one, but if you move in the left model perspective, you'll see what you see in the right hand side kind of follows along. There's a slight delay though, it's a little jagged, and that's because our timer is running at 100 milliseconds. If we set it to 20 milliseconds, so it's updating 50 times a second, it feels really smooth. And if you're wondering about this red dot, it's because this geometry, it's representing the target of what the camera is looking at, and by definition, the target of the camera is what's in the middle of the screen. So that's the dot. If we right-click that and hide, then you kind of have this perspective where you have these two views that are synced. And as a kind of side tip, I think it's really interesting to think about tools or processes that take advantage of the camera. So how can you have a camera where you're looking changes the geometry? And you can do that by location and target. If you draw a line between location and target, it'll draw a line from your eyeballs to like out into the world. So now, if I can go back to our custom preview components and right-click and change the viewport filter to the blue one, the extruded walls, to view perspective, the pink one to model perspective, and now we have this kind of tool environment. In fact, now I can minimize Grasshopper and maximize Rhino and kind of rotate around. We're in the same world. I can grab other geometry. I can delete geometry. I don't have to look at Grasshopper, but I've created this framework or this kind of interface where I just draw lines and walls appear. And one last detail, if you're wondering why we're getting this kind of jagged walls, that's because Rhino has a view display mode over here, preview mesh quality. If you click on high quality, it makes things a little bit smoother, but obviously the grasshopper will be slower. So now we have this kind of tool structure, draw a line, things appear, draw a line, things appear. Our like control geometry on the left is clear and separate. Our final geometry on the right is clear and separate. We get to have this kind of split screen view where we're doing one in the where we're modeling in one side and viewing the other. And I think that really something really interesting starts to happen when you start to create tools that's when you don't have to use Grasshopper anymore, but you're just in the modeling world. These tools become kind of augmentations. You know, you can imagine creating a wall. I'm going to create a box. Have the wall interface with the box. I can start to have a process that is part of my design. It's not, you know, I've not kind of outsourced or exported my design to go into Grasshopper and come back. I am in a Grasshopper environment modeling in a different way. And again, just as a reminder, these walls are the most simple form of geometry possible, or the most simple logic. It's just an extrusion. But you can imagine a lot of really interesting things happening, doing a lot of different operations on different types of geometry. A reminder that the geometry pipeline that I introduced at the very start, you can set it to input different types of things. You can copy and paste and say one to grab just the lines, another one to grab just the B-reps. You could have multiple different layers on which, you know, if you have one layer dealing with one type of geometry and another layer depending on another layer of geometry. But I think this is the most fundamental kind of underlying structure of what a tool can be and how to create an interface where you are within Rhino and within the tool at the same time, creating in the sandbox that you've created for yourself.